Unit 5, Section 2. Today we're going to talk about solving systems of linear equations by substitution. So you saw yesterday what a solution to a system is. It is the point of intersection of the two linear equations, and it is the point also that if you plug in the ordered pair, it will make two true statements from the equations of the system. So today we're going to focus on solving a system using a technique called substitution instead of graphing. Now, our technique is going to follow this key concept. We're going to solve one of the equations for one of the variables. In other words, we're going to get y by itself or x by itself. All right, and then it's going to be set equal to an expression. Then we're going to substitute that expression into the other equation and solve for the remaining variable. Finally, that gives us one value of the variable, and then we are going to take that value of the variable, substitute that into the other equation, and then we will have our ordered pair as our solution. All right, it's best to just do a few examples so you see what we mean. So remember, substitution means if two things are equal to each other, you can replace one for the other. All right, let's solve this system using substitution. We have the equation y equals negative 2x minus 9, and then we have the expression 6x minus 5y equals negative 19. Well, you can see here that this first equation states that y is equal to negative 2x minus 9. That means I can take this expression and substitute it into the second equation wherever I see a y. So I'm going to rewrite that second equation as 6x minus 5 times negative 2x minus 9, because that's what y was equal to, is equal to negative 19. Now you can see I have an equation that's just written in one variable. When I have an equation in two variables, I can't solve for either one. So if I can get rid of one of the variables, then I can write an equation that I can find the value of that variable for. All right, moving forward now, we're going to simplify, and I need to distribute this negative 5 into my parentheses. So that gives me negative 5 times a negative 2x is positive 10x. Negative 5 times a negative 9 is positive 45. All right, let's combine some like terms. That gives me 16x is equal to, and I'm going to subtract 45 over to the right-hand side. And when I do that, I'll end up with negative 64. Dividing off the 16, now I'll have negative 64 divided by 16. This gives me an x value of negative 4. Now, once I've found one of my values, or one of my variables, I can take that value and go back to one of the two original equations, substitute it back in for x, and solve for y. So let's substitute it back into that first expression that says y equals negative 2 times my x value. Well, we just found the x value was negative 4 minus 9. So that gives me a negative 2 times a negative 4. We're going to simplify the multiplication first. Negative times a negative is a positive 8 minus 9, and that gives us y equals negative 1. So we've found the ordered pair xy, that's negative 4, negative 1. This is where these two linear equations would cross on the xy plane, and therefore this is the solution to that system of linear equations. All right, let's try another one, solving by substitution. In our second one, we have y equals 3x plus 14, and we have y equals negative 4x. Well, they're both solved for y, and they're both set equal to y. So this actually is an interesting case because they're both set equal to y, and we can just set the two equations equal to each other. So negative 4x equals 3x plus 14. We'll subtract our 3x over. That gives us negative 7x is equal to positive 14. Divide off the negative 7, and we end up with an x value of negative 2. All right, once we take that negative 2, it doesn't matter which of these two equations we plug that negative 2 back in for, we will get our y value. Y is equal to negative 4 times whatever the value of x is, which is negative 2, and that means y is equal to negative 4 times negative 2, and that's 8. So here's my ordered pair. I have an x value of negative 2, a y value of 8, and so the ordered pair negative 2, 8 is the solution to this system. And if I were to graph these two linear equations, I would see that they'd intersect at negative 2, 8. All right, flipping the page to example 3, solve another system by substitution. I have x minus 6y is equal to negative 7, and I have 4x plus y is equal to negative 3. Now the tough thing about this is that neither one of these are already solved for a single variable. So let's take this top equation and let's move this negative 6y over to the right side so that we get one equation solved for x. So this would be x would be equal to a positive 6y minus 7. Notice that I put that negative 6y in front of the negative 7. When I moved it over, it became positive. So x is equal to this expression 6y minus 7. I can take that 6y minus 7 and substitute it into that second equation wherever I see x. So let's write that second equation now only in terms of y. So 4 times 6y minus 7, because that's what the value of x is equal to, plus 1 more y is equal to negative 3. All right, and we just follow that equation and substitute in that expression. Now to simplify, I need to distribute my 4 in. So I have 24y minus 4 times that 7 is 28 plus y is equal to negative 3. All right, we're going to add the 28 over, and we're going to combine the 1y and the 24y to give me 25y is equal to negative 3 plus 28 is positive 25. Dividing off the 25 now, not 22, dividing off the 25, we get a y value of 1. Okay, once we found our y value, we can go back up to one of our two original equations, or I can even use this second modified equation here to figure out what my x value is. So x should be equal to 6 times the y value, which we said was 1, minus 7. So x should be equal to 6 minus 7, and that's going to give us negative 1. So the ordered pair here, I have an x value of negative 1. I got a y value of positive 1. My ordered pair should be negative 1, 1. And that is the solution to my system of equations. And that should be my intersection point that I would see that these two lines intersect at, okay, if I were to graph them. All right, our final example for today, we got a word problem. We got a comedy club that earns $1,088 from opening night performance and $1,183 from a second performance. On opening night, the club sells 68 adult tickets and 136 student tickets. For the second performance, the club sells 79 adult tickets and 140 student tickets. What is the price of each type of ticket? I'm going to underline this last sentence because this tells us what we need to be looking for here. All right, what are the price of the two ticket types? And so that's how we're going to set up our variables. We're going to say x is going to be equal to the price of the adult ticket, and y is going to be equal to the price of the student ticket. All right, now we're going to go back through and we're going to write some equations based off the information they gave us. In this first line here on opening night, the club sells 68 adults, so that would be 68x, plus another 136 student tickets, so that's 136y, and they took in a total of $1,088. All right. The next equation, and the next one in our system here, should be 79 adult tickets. So that's 79 times x. That's how much money they brought in from adult tickets. And then 140 y for a grand total of $1,183. All right, now we're going to solve this system. And this is going to be a tough one to do by substitution. So actually, why don't we go to our graphing calculator, and we're going to graph these two linear equations, and we're going to look for the intersection point. So in order to get these guys ready, we're going to put these in slope-intercept form, y equals mx plus b format. All right, now in order to do that, we're going to subtract over our 68, so we got 136y equals negative 68x plus 1,088. And then we're going to divide off that 136. So I'm going to put this in parentheses and a division symbol with 136 there at the end. And that's going to give me my first equation there for opening night. All right, following that same format, I'm going to find the next equation in slope-intercept form. And the way I'm going to do that, I'm going to subtract over that 79. So negative 79x plus 1,183. But then remember, I'm going to divide over that 140. All right, so let's go to our graphing calculators now with that first one of negative 68x plus the 1088. Close your parentheses and divide that by 136. All right, and our next equation, and we'll do the same thing, open up set parentheses, and negative 79x plus 1183. We can take a look at our graph, and it looks like we can see where they intersect just barely. So we're going to go back to our calculate menu, second function, trace. This is our calculate menu, down to number 5, intersect. And again, it's just going to put the cursor on one curve. Go ahead and press enter. It will jump to the second one, press enter. And then finally guess, press enter again. And the intersection point is at 7, 4.5. So x is 7 and y is 4.5. So that means x is $7. That's the cost of an adult ticket. And y was $4.5. That was the cost of the student ticket.